This video is for homework 8, question 2, and in the question 2, we know that n is a Boolean process with a parameter lambda, and the probability is different if the k is equal to odd, or when k is even. There would be two situations, and in this question, these two situations will influence the probabilities densities distribution, and this is the key we need to use and get the result of what we want. And for the first question, we need to get the probability when xt is equal to 1. And however, since we know that there would be there would be two situations. The first is when k is odd and when k is even, and when we just put the value into these equations, the probability of the Boolean process probability equations, and we would find that there would get two different answers, and there are some secrets. There are some keys to calculate that when we put the odd numbers into odd k into the equations, and when we put the even k into the equation, we will get a very long equations, one formula, and when we do some sum or minus process, we can get very interesting equation, and this equation is just equal to the result we want. And we find that when in the first we find the xt equals to 1, which means that n is the k's value is odd, so we just put all the equations and we can get this number. And also the expression of xt would be equal to the value 1 multiply the probability xt equal to 1, and plus the minus 1 multiply the probability xt equals to minus 1. And finally, since we can use the result from the first question, the probability of xt equals to minus 1 or xt equals to 1, and using these results we can find the expression of the xt, and then we will calculate the autocorrelation of the T1 and T2. So we just we use the formula to get the result. We put different the different t and also the different value of the probability xt, and we know that when the expression of xt1 multiply xt2 can be divided into 1 multiply probability xt1, the probability of xt1 multiply xt2 equal to 1, plus minus 1 multiply probability of xt1 xt2 equals to minus 1, and using that we can finally get the autocorrelation of T1 and T2, and this number is just related with the time with the T2 and T1. So, but however, the expression of xt is not related. How to say? is not a constant, and since the expansion of xt is not a constant, and the although the correlation of t1 and t2 is a function related with the time, but the expansion doesn't. So the last question is the xt and is not wide strict